This conference will now be recorded.
Okay, welcome to my second session, Exadata Tutorial. So today I will discuss about the Exadata Machine Architecture. So this is Exadata architecture. So basically, Exadata provides a highly available, high-performance platform for Oracle database, both based on the cluster architecture and which is supported by Oracle. So in that, basically, the fundamental architecture underpinning Exadata is the same core architecture that underpins Oracle RAC software. And Exadata features have like shared storage and storage network and uh, high bandwidth means cluster interconnect, shared cache, and server cluster. So these are the key element you can say for Exadata architecture. So in shared storage, Exadata provides intelligent high performance shared storage to both single instance and rack implementation of Oracle database using Exadata storage server technology. And storage supplied by Exadata storage server is made available to Oracle databases using the ASM feature of Oracle database. So ASM basically add resilience to Exadata storage by providing a mirroring schema that basically can be used to maintain redundant copies of data on a separate Exadata storage server. So this basically protect against data loss if storage server is lost. So normal protection ensures that 2 copies of data are maintained on separate Exadata storage servers, while high-level protection maintain 3 copies of data on 3 separate Exadata storage servers. So this is the important point for shared storage. And storage network, basically Exadata X8 contains a storage network based on RD remote directory memory access over converged Ethernet, that is ROCE. So this provides basically high bandwidth and low latency access to the Exadata storage server. And fault tolerance is built into the network architecture through the use of multi-redundant network switches and network interface bonding. So this is ROC benefit which you get in network. And server cluster is the third elements or sorry third elements and component of Exadata architecture. So the database server in Exadata are designed to be powerful and well balanced so that there are no bottlenecks within the server architecture. Okay, so they are equipped with all of the components required for Oracle RAC and enable customer to easily deploy Oracle RAC across a single Exadata database machine where processing requirement exceed the capacity of single database machine. So customer can join multiple database machines together to create a single unified server cluster. So Oracle is giving 2 options. And the fourth component of Exadata storage architecture, Exadata architecture is cluster interconnect. So as I said, the high bandwidth and low latency characteristics of the ultra-fast ROCE network are ideally suited to the requirement of the cluster interconnect. Okay, because of this, Exadata X8 is configured by default to also use the RDMA network fabric as both the storage network and cluster interconnect also. So we have two network. One is storage network and another is cluster interconnect. And the another component of Exadata architecture is a shared cache. So like in rack environment, the instance buffer caches are shared. If one instance has an item of data in its cache that is required by another instance, so data will be shipped to the required node using the cluster interconnect. So this key attribute of the rack architecture significantly adds performance because the memory to memory transfer of information via the interconnect is significantly quicker than the writing and reading the information using disk. So with Exadata, the shared cache facility uses the InfiniBand based high performance cluster interconnect. So that is another things related to Exadata architecture. I hope it is clear. Yeah, now come to remote directory memory access. So this is RDMA. So as you can see in the figure, we have storage server, we have database server. In database server, we have memory region and CPU. In a storage server, we also have memory region and CPU. And we have RDMA write and RDMA read. So it has the capability for one computer to access data from a remote computer without OS or CPU involvement. So RDMA is the ability for one computer to access data from a remote computer without OS or CPU network. And the network card directly read or writes memory with no extra copying or buffering, resulting in a very low latency. So RDMA was introduced to Exadata with InfiniBand, and it is a foundational part of Exadata's high performance architecture, you can say that. And RDMA enables several unique Exadata features such as a direct to write protocol and a smart fusion block transfer. So RDMA over Converged Ethernet ROCE is a set of protocols defined by an open consortium developed in open source and maintained in upper stream Linux. So ROCE's protocol enable InfiniBand RDMA software to run on top of Ethernet. So RDMA and ROCE basically combined for these things, and this allows the same software to be used at the upper levels of network protocol stack while transporting the InfiniBand packets across Ethernet as UDP over IP at the lower level, because the IP API infrastructure is shared between InfiniBand and Ethernet, and all existing InfiniBand RDMA benefits are also available on ROCE, including over a decade's worth of performance engineering on Exadata. So this is the feature basically by that Exadata is faster in terms of performance. So these components basically help in that. Now, third is RDMA over converged Ethernet. So as you can see, we have RDMA application here, and then API, then RDMA API, then transfer protocol, then network layer, then ROCE v1. Here we have UDP, IP, ROCE v2, then Ethernet link layer. So these are the components we have in that. So ROCE is a network protocol defined in the InfiniBand Trade Association, that is IBTA standard, and allowing RDMA over converged Ethernet network. So we can say that it can be regarded as the application of RDMA technology in hyper-converged data center, cloud storage, and virtualized environment. And it possesses all the benefit of RDMA technology and the familiarity of Ethernet. So RDMA over Converged Ethernet ROCE is a standard protocol which enables RDMA's efficient data transfer over Ethernet networks, allow transport of offload with hardware RDMA engine implementation and superior performance. So ROCE is a standard protocol defined in the InfiniBand Trade Association and is standard. So ROCE makes use of UDP in encapsulation, allowing it to transcend layer 3 networks, and RDMA is a key capability natively used by the InfiniBand interconnect technology. So both InfiniBand and Ethernet ROCE share a common user API, but have different physical and link layers. So this is figure in showing. So it does this by encapsulating an IB transport packet over Ethernet. So Exadata take care of all performance and tuning work under the ROCE configuration, and nothing is required by the user. So this is a important point in this slide actually. Clear? Now come to Exadata network architecture. So this is the glance of Exadata network architecture. So it has many things. You can see Ethernet switch, PDUA, PDUB, and then RDMA network fabric switch, RDMA network fabric switch, and you have Exadata database server and Exadata storage server. So starting with Oracle Exadata System Software Release 19.3 and Oracle Exadata Database Machine X8M. RDMA over Converged Ethernet ROCE is used for the RDMA network fabric instead of InfiniBand. So this is the important point, please remember. And RDMA over ROCE network fabric uses different switches and cables from those used by RDMA over InfiniBand network fabric. So in this figure, you can see that this is one switch and this is another switch. Okay, and to deploy Oracle Exadata database machine ensures that you meet the minimum network requirement. So Oracle Exadata base machine requires a minimum of 3 networks, and there are interfaces available for additional networks. So each network must be on a distinct and separate subnet from the others, and Oracle recommends one common additional network for backup, which you can configure with OEDA that we will discuss later. And management network required network connect to your existing management network and is used for administrative work for all component of Oracle Exadata database machine. So it connects the server and integrated lights out manager, that is ILOM. So this is ILOM. So you can see that ILOM is there with Ethernet switch and switches connected to Ethernet switch in the rack. Okay, so these ILOM on both the side connected to this switch, and each database server and storage has 2 network interface for management, and one provides management access to the operating system through embedded NETO. So NETO is this. So see, this is NETO, this is NETO. So both the side it's there, and this is 2 socket system. Or you can go with any MO net net1 Ethernet port on Oracle Exadata database machine 8 socket system, and the other network interface provides access to the ILOM through the net MGT Ethernet port, and Oracle Exadata database machines are delivered with NET MGT and NET 0 or any MO, any T0 ports connected to the switch, Ethernet switch in the rack. So this is these things here, and the NET0 or an NEMO or NET0 port on the database server should not be used for client or application network traffic, and cabling or configuration changes to these interfaces on Oracle Exadata storage server is not permitted. So this is important things. And client access network, basically required network connects the database server to your existing client network and is used for client access to the database server, right? So application access the database through the network using scan and rack virtual IP addresses, and database servers support channel bonding to provide high bandwidth or ability for client connections to the database. And Oracle recommend channel bonding for the client access network. So this is important thing related to client access network. So suppose if your system will use more than 10 VIP addresses in the cluster and you have VLAN configured for the Oracle cluster client network, then you must use 3-digit VLAN IDs. Okay, do not use 4-digit VLAN IDs because the VLAN name can exceed the 15 character operating system interface name limit. So these points you should remember. And additional network is optional. As I said, database server can connect to the additional existing network using the available open ports, which is not using by the management and client network. So we have management network, we have client network, we have RDMA network fabric based on ROCE, and bond ETH0 can be either copper or optical links. So this is bond NETH0. So this is the network. Okay. Now, what is RDMA fabric network, or you can say private network? So this network basically connects the database server and storage server using the RDMA over InfiniBand network fabric switch, or RDMA over ROCE network fabric switch on the rack. So this is there, RE1, RE1, RE0, RE0. And Oracle database uses these network for Oracle rack cluster interconnect traffic and for accessing data on Exadata storage server. So this non-routable network is fully contained in Exadata database machine and does not connect to your existing network. So this network is automatically configured during installation. So important thing, this is the important thing. And RDMA over ROCE network fabric is available starting with Oracle Exadata Database Machine X8M. So please remember this line also. And all network must be on distinct and separate subnet from each other. So for better security, and the management network should be isolated from all other networks. So in this diagram, you can see how many components we have: one Ethernet switch, one Oracle database server, one Oracle Exadata storage server, two ROC switches, and two power distribution units, that is PDUA and PDUB. So if I highlight this, so this is one component, two component, three component, and four component, five component, and six component, and seven components, right? So these two are related to power, as I said. Okay, and this is Ethernet switch, and these two are the switches, which is ROCE switches, you can say, or you can say RDMA. Okay, and This is one database storage server, and this is the second Exadata storage server. So in network architecture, you have these components. Clear? And there are three networks shown in the diagram, that is client access network and management network and the private ROCE network. So the client network access network is bonded, that is bond ETH0. This is client network and connect to the net 1 and net 2 of the database server, and the network management connects to the PDUs and Ethernet switches. Okay, from the Ethernet switch, it connects to NET0 and ILOM of the database server and the Exadata storage server, and to each of the ROCE switches, and the private ROCE network connects RE0 and on the database server through one ROCE switch to REO on the Exadata storage server, and RE1 on the database server through the other ROCE switches to RE1 on the Exadata storage server. Okay, so in the end, the bond ETH0 can be either copper or optical links. So that is have option. Okay, so this is Exadata network architecture, very complicated actually, but it is easy to understand if you go through one by one. Okay. Now, what is leaf switch topology or topology in Exadata? So if you can, in the diagram, you can see that the two leaf switches in Exadata X8M, two full rack are connected to the database server, Exadata server, and to each other. Okay. And on each server, each ROCE fabric port is connected to different leaf switch. So for each switch, for each server, the ROCE fabric ports RE0 and RE1 are connected to the switches such that approximately half of the REO ports are connected to each switch, and approximately half of the RE1 ports are connected to each switch. So if you see previous diagram, so I'm talking about this. Okay. Sorry. And the leaf switches are connected to each other via 7 interface switch links. Remember that. So all the connections are pre-cabled in the factory. Okay, you don't need to do this. And Exadata X8 M8 socket has essentially the same topology, and except that each of the database server has 4 dual port ROCE network interfaces with connections spread between the leaf switches. So in Exadata X8 M2 full rack has different switches, and here it has 4 dual port in Exadata X8M socket. Okay. Now scale performance and capacity beyond a single rack. Okay. So what is that? Exadata Database Machine 8M can be interconnect to scale beyond the performance or capacity of single rack configuration. So you can scale up to 18 rack by simply adding some cabling between the via ROCE network fabric, and larger configuration can be built with an external ROCE switches. Connected racks must contain Exadata ROCE hardware. So Oracle engineered system 8 racks, quarter racks, and elastic configuration are connected to other rack in the same fashion as larger racks are connected to each other. So we can say that a spine switch must exist in each rack in order to multi-rack with other racks. So this is talking about one, and this is talking about many. Okay, so it provides scalability. Clear? Now Exadata 2 rack case leaf spine topology. So what it has? So when up to 8 racks are connected to form a large scale database grid, the ROCE network is modified to resemble a fat tree topology by adding a spine switch to each rack, and the database server and storage server connections to the leaf switches remain unchanged. So this is important thing. So in a standard alone Exadata rack, each leaf switches has 7 links, okay, that connect it to the other leaf switches in the rack. So when multiple racks are interconnected, these 7 links plus one separate link are redistributed to the spine switches. So in the diagram, you can see a 2 rack example. So in the diagram, the 7 inter-switch links that originally connected to the leaf switches plus one separate link on the each switch have been redistributed so that each leaf switches has 4 links to each spine switch. So there are no direct links between spine switch, and there are no direct links between leaf switches. Okay, so this is the diagram explanation. So we have these three, three like this. Okay, 1, 2, 3, 4. 1, 2, 3, 4. So this is 4 links and 3 these things. Okay. Now multiple rack is up to 8 racks. So what is that? To interconnect 8 racks, the 8 leaf to spine links on each leaf switches are configured to provide exactly one link to each spine switch, and for configurations between 2 and 8 racks, the 8 leaf to spine links on each leaf switch are distributed as evenly as possible among the total number of spine switches. So if you count 1, 2, 3, 4, 5, 6, okay, and here 1, 2, 3, 4, 5, 6. So here 1, 2, 3, 4, 5, 6. So you can see that. Okay. Now multiple rack case 9 to 18 racks. So what will happen in that? So to interconnect between 9 and 8 racks start by connecting the first 8 rack, which we described in the previous slide, and then on each rack from 9 through 18, remove the 7 inter switch connection between the leaf switches. Use the 7 newly available ports along with one separate port on each switches to connect each leaf switch to every spine switch in racks 1 through to 8. So in this diagram, you can see that ROCE network connection inside 1 to 8 are not changed when adding racks 9 through 8. So this is additional things you can add in this. Okay. Now, what is Exadata software architecture? Okay, so we have Exadata hardware architecture and we have Exadata software architecture. So this is the diagram of software architecture where you can see that single instance database, rack database, and ROCE network. Then you have Oracle Linux, where you have Cell SRV, IURM, MS, RS, and Exadata Cell. And in database server, you have DBRM, DSKM, ASM, libcell, MSRS, and distribution.bin. And in rack, you have multiple things. Okay. So if you are connecting through this, so you have DMCLI or DCLI uh, command line things. Okay. And if you are connecting through enterprise manager, so you have this also. So this Exadata-based machine software include components on the database server and on the Exadata cell. So starting with Oracle Exadata-based machine X8 M2 socket, Oracle Linux KVM is the virtualization technology for systems that uses ROCE network fabric. So the ability to run Oracle Linux without OVM remains and is the only option for 8-socket database server. Okay. So Exadata X8 M database server can run Oracle database 11G release 2, 12C, and 18C and 19C. And database server can be configured with all supported Oracle database software releases. But for Oracle Grid Infrastructure, 19C is required to support Oracle database 19C. Okay. And the patch release of Oracle software must be compatible with the Exadata storage server software and other Exadata software components. So you can check Oracle support note. Uh, I'm writing here. That is 888. Yes, actually, battery off. So triple A 4 time 8 and 28.1. So this is the Metalink note, which you can go through that. Okay. And ASM is required and provides a file system and a value manager optimized for database. Okay. So Oracle database communication with Exadata cell by using a special library called libcell. So in combination with the database kernel and ASM, libcell transparently maps database IO operations to Exadata storage server, which enhance the operations. And libcell communicates with Exadata cell by using the IDB, that is Intelligent Database Protocol. And the IDB protocol is unique Oracle data transfer protocol that serves the communication protocol among the Oracle ASM database instances and storage cell. So the database resource manager DBRM so is integrated with Exadata storage server IO resource management, that is IORM. Okay, and IORM work together to ensure that IO resources are allocated based on administrator defined priorities. Okay, and diskmon basically checks the storage network interfaces state and cell liveness, whether cell is live or not. Okay, and it also perform DBRM plan propagation to Exadata cell. So diskmon uses a node-wise master process, that is diskmon.bin. If you see in the diagram, this is okay. And one slave process, that is DSKM. So this is the slave process. And for each RDBMS or ASM instance. So the master performs the monitoring and propagates state information to the slave, and the slave uses the SGA to communicate with RDBMS or ASM process. If suppose failure in the cluster, then diskmon perform IO fencing to protect data integrity. And CSS, cluster synchronization services, decides what to fence. So the master diskmon starts with the cluster where processes, and the slave diskmon processes are background processes that are started and stopped in conjunction with the associated RDBMS or ASM instance. And you see MS is there, that is management server on a database server, provides a set of management and configuration function, and it works in cooperation with the DBM CLI. Okay, and a command line interface, as I said, and each database server is individually managed with DBM CLI, and DBM CLI can be used only from within a database server to manage that server. However, you can run the same DMCLI command remotely on multiple node with the DCLI utility. So for multiple node, you have DCLI utility. For single instance or single database server, you have DBM CLI. So MS is responsible for sending alerts and collect some statistics and restart server, that is RS. RS is used to start up or shut down MS and monitor MS to automatically restart if it is required. So RS process, RS is responsible for that. Okay. So this is a typical configuration where a single ASM cluster is used to consolidate storage for all of your database. Or alternatively, you could configure multiple separate ASM cluster, each with separate disk groups. So you have that option also. Okay. If you see this thing also, uh, that Oracle Linux provides the Exadata server operating system, 64-bit, and Cell SRV is the primary Exadata storage server component and provides the majority of Exadata storage services. So Cell SRV is a multi-thread server. It serves simple block requests such as database buffer cache read and smart scan request, such as table scan with projections and filter. And Cell SRV also implement IORM, which works in conjunction with DBRM to meet out IO bandwidth to the various databases and consumer groups that are issuing IOs. So finally, it collects numerous statistics relating to its operation. So Oracle database and ASM processes use libcell to communicate with cell SRV, and libcell converts IO requests into messages that are sent to cell SRV by using the IDB protocol. Okay. And management server provides ISET Exadata cell management and configuration functions. It works in cooperation with the Exadata cell command line interface, that is cell CLI. So each cell is individually managed with cell CLI, and cell CLI can be used only from within a cell to manage that cell. However, you can run same cell CLI command remotely on multiple sets with the CLI utility, and that is okay. Same thing which I said. What is if you have mixed database server? So database server 1, database server 2, Exadata storage server have MS, RS, cell SRV, and a cell of L.SRV. So Exadata storage server contains separate offload server for each database releases, so that it can fully support all offload operations. And offload requests coming from Oracle database 12c are handled automatically by a release 12c offload server, and offload requests coming from Oracle 19c database are handled by 19c offload server. Okay, so the offload server are automatically started and stopped in conjunction with cell SRV. So there is no additional configuration or maintenance procedure associated with them if you are using two database version like 12c and 19c. Clear? Now, this is high capacity storage server where you have disk storage entities and relationships. So if you see the diagram, we have LUN, we have cell disk, and then we have grid disk or grid disk hotpot. Okay, and that two disks are visible to ASM. And if you see the top of the things, you have physical LAN, cell disk, grid disk, and ASM disk. So like that, they have figured in this slide. So each Exadata high capacity storage contains 12 hard disk drives. Remember this. And Exadata cell software automatically senses the physical disk in each storage server. So as a cell administrator, you can only view a predefined set of physical disk attributes, and each physical disk is mapped to a logical abstraction called a logical unit, that is LUN. So LUN exposes additional predefined metadata attributes to a cell administrator. You cannot create or remove a LUN. They are automatically created. So remember this important point. In interview, they can ask how many hard disks are available for Exadata high capacity storage server, or second interview question they can ask, can you create a LUN in the Exadata high capacity storage server? So you have the answer, which I said no, they are automatically created, and the disks are 12. Okay, so cell disk is a higher level abstraction that represents the data storage area on each LUN. So after cell disk is created, it can be subdivided in one or more grid disks, which are directly exposed to ASM. Okay, so placing multiple grid disks on a disk allow the administrator to segregate the storage into pools with different performance characteristics. Suppose cell disk could be partitioned so that one grid disk reside on the highest performing portion of the disk, and the outmost tracks on a hard disk drive, whereas second grid disk could be configured on the lower performing portion of the disk, so the inner tracks. Okay, because we know that outer track data is faster and inner data track is slower. So fast grid disk might then be used in ASM disk group that houses highly active, or you can say hot data, while the second grid disk must be used to store less active data files, that is cold. Okay, so these are the things which makes Exadata is more better in terms of performance. Okay, so another question is interview, cell disk can be partitioned? Yes, cell disk can be partitioned. Okay, so when entire cell capacity is required for a single database, or where it is difficult to clearly define hot and cold data set, so Exadata cell administrator will usually define a single disk, grid disk containing all the space on each cell disk. Okay, so in the diagram where one or two grid disks are created from the space on a cell disk, so this does not does not constrain a limit of two grid disks on a cell disk. In fact, when Exadata is initially configured, three grid disks are defined mostly of the cell disk. So that is that thing we will discuss later about this two disk grid disk or three grid disk or four grid disk. Okay, now another things is flash storage entities and relationships. So what is flash? So in the diagram you can see that you have flash LUN, then you have cell disk, then you have flash cache and flash log. So you need to create flash cache, you need to create flash log. So each Exadata X8M socket 2 high capacity storage server contains 25.6 TB of high performance flash memory distributed across 4 PCI flash memory card. So remember that. So it means each flash card has a capacity of 6.4 TB, huge. Okay, so each flash device is like a physical device in the storage hierarchy, and each flash device is visible to the Exadata cell software as a LUN. Okay, and the initial cell configuration process create flash based cell disk on all the flash devices. By default, nearly all the available space on each flash based cell disk is allocated to Exadata Smart Flash Cache. Excuse me. Only a smart portion is allocated to Exadata Smart Flash Log. Okay, so all portion is allocated to Smart Flash Cache. So remember these things. Okay. And as I said that if you go with next slide, so here you are creating grid disk, you are creating flashback, flash cache, you are creating flash log. So you have flash LAN, cell disk, then grid disk, then flash cache, then flash log. So Exadata X8M2 socket extreme flash storage server contain 8 high performance flash drives. Remember that 8 high performance, and each flash drive has a capacity of 6.4 TB, as I said. And like Exadata high capacity storage server disk and flash devices, each flash device or drive is visible to Exadata cell software as a LUN, and each LUN contain a cell disk. And by default, 95% of the available space on each extreme flash cell disk is used for data storage. So this space is allocated to grid disks that are exposed to ASM in the same way as the disk space from a high capacity storage server. and all of the remaining 5% is allocated to Exadata Smart Flash Cache, and a small amount is allocated to Exadata Smart Flash Log. So this is the important point regarding Flash Cache, Flash Log, and grid disk. Now you have uh, HC and EF storage server. HC means high capacity and EF means extreme flash storage server. Contain 1.5 TB of persistent memory in front of flash cache. So that is, therefore, each persistent memory module has a capacity of 128 GB. Okay. So essentially, each persistent memory is like a physical device in the storage hierarchy. So each persistent memory module is visible to the Exadata cell software as a LAN, and the initial cell configuration process creates PMEM, that is a persistent memory module based cell disk on all the persistent memory modules. By default, nearly all the available space on each PMEM based cell disk is allocated to Exadata Smart PMEM cache. Only a smart portion is allocated to logs. So same way, flash cache and flash log, you have PMEM, persistent memory module cache, and persistent memory module log. Okay. Now disk group configuration. So this disk group configuration, you can see that by create disk group command, you will create. You have Exadata cell. In that you have cell L1, cell L2, cell L3, and you have cell L1 for failure group, and you have cell L2 failure group, you have cell L3 failure group, you have data one, you have FRA1. So after grid disk are configured, ASM disk group can be combined to consume Exadata storage. So this slide basically example of two ASM disk group are defined. That is, data one disk group is defined across all of the red grid disk, and FRA1 disk group is defined across the blue grid disk. So when data is loaded in each disk group, ASM evenly distribute the data across all the grid disk in each disk group. So we know that ASM do rebalancing and all internally. So using normal or high ASM redundancy in conjunction with at least 3 failure groups for each disk group is recommended. Okay, uh, in Exadata, and this will ensure that at least two copies of data are maintained to protect from storage failure. And external redundancy disk group are not supported. Remember this, because they provide no protection from storage failure. Okay, and if that prohibit the use of online storage maintenance procedures such as rolling patches, for example. So the initial configuration process for Exadata creates 3 disk groups using normal or high ASM redundancy. So the configuration of excuse me, the disk these disk group and the associated redundancy options are discussed later. Okay. So to protect against the failure of entire Exadata cell, separate ASM failure groups are automatically associated with each cell, which ensures that mirrored ASM extents are placed on different Exadata cell. Okay. And by default, when failure groups are automatically created, their names basically corresponding to the cell name. Okay. So different disk group can have the same failure groups names. Okay. So you remember that. For example, you have data one disk group as a failure group name cell1, and FRA1 disk group also has a failure group name cell1. So that is I'm talking about. So don't get confused. Oh, finish. Okay. So thank you for joining this session. I hope it is clear, and These are the links where you can give the feedback and you can register for next session. Okay, and thank you and happy weekend. And if you have any questions, you can ask. And if you like the session, then please subscribe, hit the bell icon, do the comment, like, and share in your circle.